Hello and welcome back to my Java tutorial series. This episode, episode 14, we're going to we're going to get into quite some awesome stuff. We're going to do introduction to some swing stuff, as well as making our own window and drawing stuff to it using java.AWT, or AWT, which you should know was the I think Applied Windows Toolkit. Something Windows Toolkit. Maybe Application Windows Toolkit. That sounds about right. Either way, it has the same meaning. So we're going to import two things. Well, we're going to import three things. We're going to import java.applet. We're going to import java.awt, all of it, and import javax dot swing and all of it. And remember, the asterisk means all of it, and when we have applet, that means we're importing that class. Main is going to extends applet. Now there's a difference between an application and an applet. An application is something like down here on my my dock, I have Minecraft. If I click it, it launches Minecraft, the game, and that is an application because you just click it right here and it'll run on your computer. An applet is something you would normally put into something, normally like a web page, like all those web games you play. Those are applets. Now the only reason I'm making this applet so you can put it into a web page, and you can also add it to a JFrame, which is going to be our main window. But we'll get to that. So it's also going to implement runnable, and I taught you that in threads because we are going to have some threads. Now, because this is going to have its own thread, we're just going to do a public static JFrame, which is part of swing. And a JFrame is basically what we're going to use for our window that pops up when we start it. So we're going to have a public static void main string array args. And then we're going to have several other methods, as I normally do. We're going to do public void init, that initializes it, public void run, and public void stop. Let's see, this should be implementing it. Oh wait, the string. Oh, and since it extends applet, it also wants you to have the UID, so add default serial version UID. Take away the Java doc since that's useless, and that just there. So what we're going to do is say main equals new main, and I forgot to add a public main because we also want a constructor. So when we establish main, we're just going to say frame equals new JFrame. Okay? Now, a lot of this stuff we're not going to be using in this episode, but it's how I normally do all my setup for when I'm actually making a game or an application or a utility. The other thing we need is a public static final dimension screen size, and a dimension is basically something that holds a width, width and a height, but is a dimension and it's handled by other things. The width of our window, let's make it 800 by 600, and we'll see how we implement that later. What we're also going to have is a we'll do a public static boolean is running. Okay, is running. So we're gonna do stop is just gonna be is running equals false. We'll eventually add some more things to that. So when you run, while is running. Initialization is overridden from applet. Stop is overridden from applet. And this is implemented from the thing, because initialization and stop are stuff from there. What else we want to do? We want to set the frame dot let's just set size. We're going to set the size to screen size. Oh, I forgot. Whenever it's final, we'll just do screen size. See, I don't always do that, but, normally you always do that. Because, mainly, sometimes I forget. Now, there's several other things. If you go to frame, there's a lot of things. One, all these add things, which are you can do with every swing component. And then you can, the other things, these are all static and stuff. Yeah. You can validate, you can update, there's a large amount of things you can do with any swing thing, but mainly what we want to do with it, let's just set title. And up here we'll make another public static final string. We'll just call it title equals episode 14 testing. So then right up here, we'll just set it to title. Some other things we might want to do, I know what we definitely want to do, but I also want to do that. Look through it, just so one, so you can see, and two, so I can see if there's anything I might forget, because I obviously don't want to forget anything when I'm teaching you how to do stuff. So, there's a whole bunch of gets and sets. I think what we're just going to do is set default close operation, jframe dot exit on close. So that means whenever you press the X button, it'll shut down the program. Frame dot set, we'll just set it to visible true, because else nothing will work. So we'll just run it and see what we get. Oh yeah. What we want to do is do frame dot add our applet, because else it would just be a blank. It'd be a blank thing. So now it would be a blank thing, but once we actually make our applet do stuff, then it'll have it inside of it. So what we want to do, set preferred size. Preferred might have one F. I just did a couple things backward, and we'll do screen size. Just let me see. Oh, it has two R's. Okay. So that means this set the applet's preferred size. We don't want to set the frame size, because we want the applet to have a size. And then what we're going to do frame.pack. Now what pack does, it looks at everything that's on it. So far we only added our main, which is our applet, which already has a size. So it looks what's in it and sets the frame size to whatever's in it. Well, to all the stuff in it, which there's only one thing, so it should pop up. Let's run it as an application, since we don't want it to run as an applet. Save that, and we run it. It pops up over here, it's main. We should have a window popping up. Here we have a window, it's called episode 14 testing. Now the dimensions of this window is probably 800 wide and 600 tall. So now we have a window. Ta-da. Now what we're going to do is, when we run, the first thing we want to do is initialize. And also, when it's done, we want main dot, I think we can just, I don't know, maybe main dot start, which extends applet. So let me look at start. It's called, okay, so we start it. So what, the other thing we want to do besides our two things, we want to start public void start. And the only thing we really want to do here, well, no, we want to initialize, and then we want to do new thread this dot start. And we can do this because this implements runnable. So it'll initialize whatever the hell we want to initialize, then it'll run. And what we're going to do in here, we're going to do tick, and then render. And then what'll happen is this while loop will run every single millisecond. Which, if we made it run that fast, it's gonna do hell to our computer. So what we're gonna do a try thread.sleep. We'll just do 50. And then, of course, catch the interrupted exception. And let's just not do anything with it because it's not gonna get interrupted because we don't have anything interrupting it yet. I mean, we can eventually do something with it, but it's no big deal right now. So we're gonna set up a public void tick, and then we're gonna do a public void render. So basically, if you're doing a game, because normally when you're doing an app, like say an app like Microsoft Word or something, you normally wouldn't have things running on a loop like we are in a game. You would have things just whenever you click something, it would send an event to something else that would then trigger it. But right now, this is like a game engineering structure we're doing as opposed to an application because it just keeps running on a loop. So basically, it ticks every single tick, which since we're waiting 50 milliseconds, there should be 20 ticks in a second. So every 20 times a second it'll tick, and then it'll render after it ticks, because we want it to render after it ticks. If we ticked after it rendered, then it would be rendering the wrong thing, and all information would be 50 milliseconds off. You might not think that that's much, but it is that much. So that's what we do. So now, what we want to do is render. We're going to do, actually in initialization, we're going to say, we're just going to set up a public image screen. And what we're going to do here is we're going to do screen equals new, maybe it's create a volatile image. We should get an error, but it shouldn't be that I can't find it. Add arguments. Yes, create new volatile image. Now what we're going to do here is we're going to create another dimension and call it game size. Because what we want to do is, not everyone wants to do this, but we're going to make this half the size of the screen. So that way whenever we draw something, it takes up twice as much as possible. So normally we would draw things pixel by pixel, but this time we're drawing them 2 pixels by 2 pixels for every pixel in our game. That only means that movement will be smoother than the pixels, but it also means you can see things easier. You can just use smaller images. So what we're going to do, we're going to create volatile image game size dot width and game size dot height. Now what this volatile image means is that this image is off screen and it's volatile, which means it only exists in the RAM of your computer. If you don't know how a computer works, there's two types. Your memory is the amount of RAM you have. My computer has 4 gigabytes. It's all it is a MacBook. Not like a Pro, but a standard MacBook. They discontinued those for a while ago. But 4 gigabytes isn't bad for a laptop. Normally desktops would have a lot more, obviously, but 4 gigabytes isn't bad. But this means, as opposed to your storage, which is your hard disk drive or your solid state drive, I'm not here to teach you about computer hardware, because then that would make my tutorials a lot longer. But basically, your RAM, when you turn off your computer when you turn off your computer, everything in your RAM gets flushed, but everything on your disk drive or solid state stays there in storage memory. So, you know, when you turn off your computer and start it back up, you still have all your files and folders, but you might not have, you know, your game still running with everything. But with the volatile image, it basically saves memory rather than drawing things straight to the screen. And so yeah, it's like a buffer, an image buffer. So we're just creating the volatile image. Now we're gonna have to do, every time it renders, we're gonna do graphics g equals screen dot get graphics, because the thing is, you can't instantiate graphics. You can't say it equals new graphics. You have to get your graphics from somewhere, and we can get it from a volatile image. So if we do G, G is a graphics device, so it basically has a lot of things for drawing stuff. And we're just going to do fill rectangle at coordinates 0, 0, and we'll make it 100 pixels by 100 pixels. Before this, and graphics is from java.AWT. We're also going to set color, and you can it's either 3 bytes or 4 bytes. It's the RGB spectrum, so we can set it to like 150, 150, 150. That'll give us I'm not sure, a little gray maybe. You can do 3 arguments like that. Oh well, you have to say new color, because a set color only accepts a color as an argument. But color accepts either 3 bytes or 4 bytes. If you add a 4th byte, that's the alpha or a transparency of it. So if we have that add transparency, we don't want transparency. So you can either create your own color, or you could just do color dot other colors. We're gonna go with cyan, since cyan's a good color. You'll notice when I click on that, there's a lowercase and an uppercase for every color. I just prefer uppercase. I don't know why, but I just prefer uppercase since they are final, and that's standard notation. Now the other thing we want to do is G dot draw image. This first one, you can see there's a lot of arguments. We're going to do draw the image screen. I think this is, I forget if this is the to or from. Now you can draw as much specified area. Let's go down to parameters, the x-coordinate of the first coordinate. Okay, destination, and then source. Okay, so I think we need to do G equals frame dot get graphics. So originally we were drawing to the screen, which is an off-screen volatile image, but now we want to draw to frame. So we'll draw screen to frame. We'll do destination coordinates, destination width and height. So I think this should be 800. It should be 400. And then it's and then we're drawing it from screen, which will be 0, 0, 400, 300, and this should be 600, my fault. And then the image observer, that's just for calling events when images are changed or stuff. We almost always set this to null. And then so our graphics, since we're creating a new graphics every time and we don't want it to get clogged up with a whole bunch of graphics objects, we're just going to do g.dispose, so it destroys the graphics object after every single tick. So if we run this right now, hopefully we'll have a rectangle, a cyan rectangle on our window. Or we could not. We set the color, we fill the rectangle, and we draw screen. Let's see, what could be wrong? Screen, then frame.get graphics. Initialize it. Wait, okay. Let's see. Destination of this. Oh, the second. Yeah, that's what I did. Okay. What? Oh no, we don't want to draw to frame. We want to draw to main, I believe. Oh yeah, because main is in there. Oh yeah, we want to do this. We just want to do get graphics. We're not trying to draw to the frame. We're trying to draw to the applet. Okay, the problem is for the renders, every time the loop runs, and we need to make is running equal to true so the loop can actually start. So now that we have all this already done, just for convenience, we're going to change this to screen size dot width, and we're going to change that to screen size dot height. That way, the main reason why we set it to all these variables is so that whenever we want to change the size, we just go and change the magnitude of that variable at the beginning here instead of going through every single reference to that video. Because if we did it that way, then we could possibly forget and get a whole bunch of errors. That's besides the point. So now if we run it, we'll almost certainly get our cyan rectangle. There it is. Now the cyan rectangle is refreshing every second. So there's something cool that can be done with that. We're going to make this rectangle move. And as soon as we're done making a move, we're just going to probably just going to end the episode. So in this, we're just going to do, we're going to declare some integers up here. Let's just do public integer x equals 0, and we're just going to do comma y equals 0 as well. So we're going to do this. We're going to do x, y. And what we're going to do after it renders it, we're going to do x plus plus and y plus plus. So this might go a bit fast, but if we run it now, it'll start going that way. Now the reason why it's drawing a whole entire line is that after we're drawing to the screen, it's not erasing for whatever reason, but as you see, it's a very large rectangle, and if you look closely on the screen, if the resolution's high enough, you can see the borders. But it's a pretty straight line right there. So the one thing that we should do is, well, there you go. Here's a moving rectangle. And what we could also do is, well, you see how when it goes to the bottom, it just glides to the floor. We'll eventually get to collision detection, but I think I'll make a different series dependent on just, like, game mechanics. I'm not sure, but we'll see. Either way, we'll continue with this next episode with drawing other things, like drawing images and some other swing things, such as adding other layouts and menus. We'll probably take out we'll probably won't establish a loop next time. But this was a pretty successful episode, if you ask me. Let me just see something. Maybe I can do like screen clear. I doubt it. I have no idea. No. I'll try this and see what it happens. This probably won't work though. Yeah, that did nothing but bad. That did nothing but bad. Before we leave, I'm just going to make something funny. If x is less than 100, x plus plus. Else, y plus plus. So what it'll do now, it'll just go that way, and it should do that 100 times, and then it should just take a beeline downwards. Okay, next episode we'll worry about erasing stuff and the other things I already mentioned. So I'm just going to do one more interesting thing. Oh, that won't work at all, will it? Yeah, that won't work. Okay, so I will see you next time, and happy programming.